सो हेलो गाइस, वेलकम बैक टू चैनल गेट टू बाइट। आज इस वीडियो में हम लोग I2C कम्युनिकेशन के बारे में पढ़ेंगे। आई एम गोइंग टू टेल यू एंड शो यू हाउ टू मेक इट्स फर्मवेयर यूजिंग इट्स डाटा शीट, एंड आई हैव मेड ऑलरेडी द code for communicating between I2C slave to I2C master, and for the same I am going to show you how to make that thing by explaining things from datasheet also and relating them directly to our code. So now let's proceed. So guys, this is the I2C communication of between two Arduino Megas, and this one COM19 is my master and this is my slave. So its simple code is, first I will directly take you to the main function. We first initialize the master, and in this we first initialize the slave. In initialize master, what we do, we just write the baud rate for our SPI communication. And in case of slave, in TWI initialize slave, we have just set our address to the WAR for slave, and we have set the control register in slave for enabling the acknowledge bit and TWINT bit and TWEN. This is TWEN makes my I2C hardware active. TWA is for sending the acknowledge bit, and TWINT is bit which tells me, which will be looped under the while and tells me which I2C session has been done. Okay, then in our main function comes our I2C address read slave, and we send TWI start first in the master, then we write the address, and in write address I have sent the slave address, and as it is for write, so it will send the 8th bit as operation 0 for writing on the slave. Okay, now if we will go to the TWI start, then its definition is normal. We have just set our control register, we have set the DWSTA bit, while के अंदर we loop under the TWINT, and this bit is set, that is TWINT is equal to 1, then it means TWINT flag has been cleared and it will come out of the while loop. And then I have just checking my status code. Now the start status code does not depend upon my slave. On successful transmission of the start signal, my status code will be updated with 08. Then I have used the write address UINT data. In this I have passed my argument as the slave address and TWDR data, and this makes my master as a master transmitter, and then I have control my TWCR, and as in this case I am writing, it's transmitting, so in that case acknowledgement is being received by the receiver, so no TWEA has been set in the write address one. Okay, then I have while looped TWINT bit for checking when my is my TWDR data hold 8-bit address data has been successfully transmitted or not, and then I am waiting for getting the acknowledged bit check acknowledge bit from the slave, and correspondingly on the acknowledge bit my status code will be updated. Now for this function in my slave, the function which I have is the address read slave. So this function does what is, this function checks when SLA plus WA has been transmitted by master, so slave is in receiving mode. Now acknowledgement is set by setting TWA bit to 1 in TWCR, thus master DWSR status code, that is this one, is updated with the status code correspondingly to the slave plus acknowledge bit. Okay, so now in this function, what I have done, I have set my control register for the slave in the slave with TWEA and TWINT and TWDN all have been set to 1. Now important thing to understand and to remember is we have to set TWA equals to 1. If we will not set TWA equals to 1, then it will not send acknowledgement bit to my master, due to which my status code will not be updated as 18. Okay, because this 18 status code, when we have successfully transmitted SLA plus R/W and plus acknowledge bit has been received by the slave. If we had not set TWA bit to 1, then on the SLA plus R/W will be transmitted, but our 9th bit will be not acknowledged. So its status code will not be 18, okay, and it will be something else, because of which this function will stuck inside this while loop. So TWA bit has to be set 1 in the slave. In slave, when slave is listening to master, whether it is listening for reading operation or for writing operation, but it should acknowledge so that master can know that okay, my slave has been successfully receive my SLA address and /data direction, also read or write operation, and correspondingly status code is updated. Then write address comes, and then comes the write data. For this write data, we have done simple thing. First we will load our TWDR with the data, and then TWSR control register will be updated with updated with TWINT and TWEN. One thing to important is when we are writing, that is when the transmitter will not set the TWA bit. Why? Because transmitter is sending the data and it will get acknowledged bit from the receiver. So receiver should set the TWA bit to 1. So correspondingly here, for this function write data, we have read slave data. Okay, so in this control register is updated with TWEA also set to 1, because it will send the acknowledge bit to the master when it receives the data which is sent by the master. Okay, so then it will loop in this for the TWINT bit, as TWINT bit will be monitored for seeing that whether my data has been successfully transmitted to slave or not. If it is successfully transmitted, then it will check for the status code, and herein TWINT bit will be monitored for seeing that whether some data has been received by the slave or not. If it receives any data, then it will check for the status code. Now in this status code, in this thing when it in the slave, when it is looped by the TWINT bit, then in this 2 operations are done for in this loop. First it will check that whether it has received the data, and it will check that whether it has sent the acknowledge bit. So in this, if it has sent the acknowledge bit also, then correspondingly its status register is also updated that my successful data has been received and acknowledge bit has been sent. So 80 will be my status code. If successful data received and acknowledge bit is not set here, so not if and TWA bit is not set, so not acknowledge bit is set, so my status code for the slave will be something else, and also my status code for the master will be something else, will not be 2-bit. Okay, so we have to make sure that the transmitter part should not set the TWA bit and slave part should set the TWA bit on receiving the data, or on receiving the data, or on receiving the address slave. Okay, so coming back to the main function, so this is my simple, and the TWA stop bit is another bit which is important, because as in my I2C there is start, address, data and stop. So stop bit is the concept for stop bit is little bit different. In this there is nothing like a status code for the master when stop bit is successfully transmitted by the master and it gets acknowledged also for it, then its TWSTA bit in the control register is cleared. Okay, so this generates the stop signal, and so when slave acknowledges the stop signal, then only TWSTA bit is cleared. If slave does not acknowledge the slave stop signal, then TWSTA bit will not be cleared and it will stuck inside the while loop. So it is important here again that in my control register I should set my TWE and EA bit also to 1, so that slave will send the acknowledge pulse. In this while loop it will wait that it has received the stop bit and it has sent the acknowledge bit. On sending the successful acknowledge bit and receiving the stop bit, its status code will be A0. Okay, so that's it. And then normal print string 0 data sent by I2C, decimal print I am printing it here, so which you can see in the here data received by I2C master and data received by the slave. So all are correspondingly being sent by the master and received by the slave. So that's it for now. Like the video, subscribe the channel and press the bell icon to get notified for new videos, and share it with your friends.